this is week 8 of 1 year with calculus, and this week we were asked to solve a definite integral from 0 to pi over 2 of cos the power of 15 theta times sin the power of 50 theta in respect to theta. You have a full week to attend this question. If you've solved it already, congratulations. If you've not attended it, well, here is your chance to see the solution. So the first thing we have to do here is to realize that this is a trigonometric question. That is, if you use inside calculus, is trigonometry. So you have to apply some laws of trigonometry. And you can remember the Pythagorean identity of cos square theta plus sine square theta is equal to 1. There are three of them, but this is one that we're most concerned about for this question. Let's make sine square theta solve the formula. We have sine square theta is equal to 1 minus cos square theta. Remove this cos square theta to the right hand side. So I'm going to use this identity to simplify this question. Here we have cos to the power of 15 theta sine to the power of 3 theta. This is equal to cos to the power of 15 theta times sine square theta times sine theta. You know that u squared times u is equal to u cubed. So sine square theta times sine theta will give you back sine cube theta, which is the same. So cos to the power of 15 theta sine cube theta is equal to cos to the power of 15 theta times sine square theta times sine theta. Sine square theta here is equal to sine square theta here, and that is equal to 1 minus cos square theta. So we just do the substitution. So all this, let's call here I, not I, let's call here J. So J here is equal to cos to the power of 15 theta times 1 minus cos square theta times sine theta. Okay? So basically what we're integrating J with respect to theta. So once we simplify what J is, we'll just put it back inside the formula. So we have J is equal to cos power of 15 theta times 1 minus cos square theta times sine theta. If we expand this bracket, let's expand from the left first of all. If we expand from the left, we have J is equal to cos to the power of 15 theta minus cos 15 plus 2 is 17. So that's cos 17 theta sine theta. Now let's expand from the right. We have J is equal to cos 15 theta sine theta minus cos 17 theta sine theta. Now this is the most simplified way. We have J is equal to cos 15 theta sine theta minus cos 17 theta sine theta. Now that we know what J is, remember J was equal to cos to the power of 15 theta times sine to the power of 3 theta. And now I find that J is also equal to cos to the power of 15 theta sine theta minus cos to the power of 17 theta sine theta. So we can replace this J here with the previous value of J. Now let's do that. If we do that, we have that our integral I is equal to this. So our integral I is equal to the integral of J with respect to theta. And this is equal to the integral of cos to the power of 15 theta sine theta minus cos to the power of 17 theta sine theta. We are integrating with respect to theta. That is the theta. Okay. If you have the integral of u plus v dx, this is equal to the integral of u dx plus the integral of v dx. So let's separate these two different integrals. The first one, we have the integral of cos to the power of 15 sine theta, the theta multiplied by the theta, minus the integral of cos the power of 17 theta sine theta d theta. Now we can solve this. If you apply a u substitution, let's say let u equal to cos theta. This implies that the u is equal to minus sine theta d theta. This also implies that the theta is equal to u divided by minus sine theta. Because we have the theta here, we have the u equal to minus sine theta d theta. Divide both sides by minus sine theta, we have the theta is equal to du over minus sine theta. Just in case you are confused how we got du, that is just the same way you have let's use the simplest way that you can know. Let's say you have y is equal to cos theta, then you differentiate, you have y over dx is equal to minus sine theta. All I do was to multiply here by dx. That's how you got the y is equal to minus sine theta dx. So in this case, we have du is equal to minus sine theta d theta, because we differentiated with respect to theta. Okay, so now we can apply the substitution. We have first of all, let u equal to cos theta. Then second of all, let the theta equal to du over minus sine theta. So if we apply that here, we have the integral I. The integral I is equal to the integral of cos to the power of 15 theta return to u to the power of 15, because you have u is equal to cos theta. If you raise cos theta to the power of 15, you're also raising u to the power of 15. So cos 15 theta will equal to u to the power of 15. Sin theta d theta. Okay, so that would have been easier if I just say let the number minus du is equal to sin theta d theta. That would be easier because I can just substitute minus du here. But since I follow this part, I'm not going to continue this. Okay, so we have sin theta here, and we have the theta is equal to what? The theta is equal to du divided by minus sin theta. Okay. The second part, we have minus the integral cos to the power of 17 theta is equal to u to the power of 17. The same reason that we have u to the power of 15 here. Sin theta, and the theta is equal to du over minus sin theta. You can now cancel some things out. Sin theta here will cancel sin theta here, and you're left with minus du. As I said before, because I could have just substituted minus du for sin theta over sin theta theta, but I didn't use it again. So sin theta here will cancel sin theta here. Sin theta here will also cancel sin theta here. So what you're left with will be, I is equal to the integral of u to the power of 15 du minus du. So I'm not doing that the minus in front here. So you have I is equal to minus the integral of u to the power of 15 du minus bracket open minus the integral of u to the power of 17 du. I'll go over this again. Here we have I is equal to the integral of u to the power of 15 times minus du. I brought out the minus because minus is constant, minus 1 is constant. So we have minus 1 times the integral of u to the power of 15 du. It's not going to be minus du again because I brought out the minus already. So it's just going to be du. So we have I is equal to the integral, so I is equal to minus 1 times the integral of u to the power of 15 du minus, so I put the minus here, times the integral of u to the power of 17 du over minus 1. The minus 1 is a constant, so I can bring it out. And that's what I did here. The integral continues, the integral of u to the power of 17 du. And that is it here. Now what do you see? You have minus times minus. Minus times minus is plus. So I can just click that and put plus over here. So all we're left with, if we simplify, let me bring this to the front because it's easier positive numbers are in front, so this minus will not get lost. So now we have I is equal to the integral. I can clean this up. So we have I is equal to the integral of u to the power of 17 du minus integral of u to the power of 15 du. The integral of u to the power of 17 du is simple as u to the power of 17 plus 1 divided by 17 plus 1. If you have the integral of if you have the integral of x to the power of a dx is equal to x to the power of a plus 1 divided by a plus 1. So here you have u to the power of 17, so u to the power of 17 plus 1 divided by 17 plus 1 minus the integral of u to the power of 15 du will be u to the power of 15 plus 1 divided by 15 plus 1. Don't forget your integral constant. But since it's a definite integral, you have the upper bound and your lower bound. The integral constant end up constant now, so I'm just going to clean it up now. So now if you simplify this, you have I, that is integral, is equal to u to the power of 18 divided by 18 minus u to the power of 16 divided by 16. But don't forget, we didn't solve for u, we solved for theta. So you have to substitute back the value for u back inside the question. Except if we said let u equal to cos theta, it's still possible to solve in terms of u. If I plug in the value of theta here, let's say theta equals to 0. When theta equals to 0, cos 0 will be 1. So u is going to equal to 1. So the new lower bound, the new lower limit will be 1 instead of 0. When theta is equal to 90 degrees, u will equal to cos 90 degrees, which is 0. So the new upper bound will be 0. So instead of integrating over 0 to pi over 2, we'll be integrating over 1 to 0. So you can just choose any way, you still get the same answer. You can choose any method you want to use. Either you substitute u into here and get your answer in terms of theta before substituting your upper and lower limit, or you change your upper and lower limit using the identity, using your substitution. It was us who added this, it was us who made this variable. Using this your use of for u equals cos theta, you can now change your lower limit and your upper limit. Change your interval there, including over. I will use the two methods just to clarify things. I'll use the two methods. So for the first one, we have to substitute u into this. So this is going to equal to cos 18 theta divided by 18. Cos 18 theta divided by 18 minus cos 16 theta divided by 16. So this is going to be our final answer. No, not really our final answer, but this is going to be our indefinite integral. If it was an indefinite integral, I would have plus c, but I'm just using the plus c because this is actually a definite integral. I've just not substituted our values yet. So let's substitute our value. When our lower, let's do our lower limit. No, this has to be the upper limit minus the lower limit. So let's do the upper limit. When theta is equal to 90 degrees, that is pi over 2, 90 degrees, then cos 90 degrees will be 0. So here we have 0 to the power of 18, which is 0, divided by 18, which is 0. So our integral, let me write it up here. Our integral I equals 0, okay? 0 minus, when theta is equal to 90 degrees, cos 90 will be 0. 0 to the power of 16 will be 0. 0 divided by 16 will be 0. So you have 0 here. Minus our lower limit. When theta is equal to 0, you have cos 0, that is 1. 1 to the power of 18, that is 1. So you have 1 divided by 18. When theta is equal to 0, cos 0 will be 1. 1 to the power of 16 is 1. And 1 over 16 will be 1 over 16. So you have minus 1 over 16 here. 0 minus 0 is just nothing, so you can just clean that off. And the minus here will multiply everything inside. So you have 1 over 16 minus 1 over 18. And this will be your final answer. But I'm not sure yet. I've still to find out. So you have 1 over 16 minus 1 over 18. So let me show you that our answer is the same if we change our lower limit and our upper limit. Okay, so let's use method 2 now. So for method 2 now, we have to change our we have to make the new lower limit and upper limit for integrating over u. Okay, when theta is equal to 0, cos 0 will be 1, so u is not equal to 1. So our new lower limit will be u is equal to 1. When theta is equal to pi over 2, cos pi over 2 equal to 0. So u is not equal to 0 as our new upper limit. So if you apply the same thing here, this is now going to be our final answer. For this question, this is going to be our final answer, and not cos power 18 over 18 minus cos power 16 over 16. This will be our new final answer. Because now we're integrating over u. You know that here you're having theta. Remember, we solved in terms of u. This was what we solved. So we're now going to be integrating over u. But now, when you're solving this, it's still going to be the same process. Even though here is the higher number, we're integrating the upper limit minus the lower limit. So it's going to be the upper limit. You're going to use the upper limit first of all. This will equal to, when u is equal to 0, here will be 0 to the power of 18. Here will be 0 to the power of 18, which is 0, divided by 18, which is 0. So we have 0 minus, when u is equal to 16, when u is equal to 0, sorry, we have 0 to the power of 16, which is 0. 0 divided by 16, 16 times 0. Minus, when u is equal to 1, that is lower limit, u is equal to 1. When u is equal to 1, you have 1 over 1 power of 18, which is 1. 1 divided by 18, that is 1 over 8. 1 over 18, sorry, 1 over 18. When u is equal to the same thing, let me just not waste time, minus 1 over 16. Multiply by minus 1, you have 1 over 16 minus 1 over 18. So, you can say they're the same. So now let's simplify. 1 over 16 minus 1 over 18 is not the best way to put it. So let's simplify. And to simplify, we're going to use the LCM of 18 and 16. So you have 1 over 16 minus 1 over 18. This is going to equal to, let's find the LCM of 16 and 18. The LCM of 16 and 18, let me not do it in my head, so I'll show you the process. So if you divide all through by 4, let's divide all through by 2 first of all. You have 9 here, you have 8 here. Divide by 9, you have 1 here, you have 8 here. Divide by 8, you have 1 here, you have 1 here. So 2 times 8, that is 16. 16 times 9, that's 4 times 3, that's 144. So you have 144 here. 144 divided by 16 should be 9, I believe so. So let's say 9. I mean, that's 9. Yeah, 144 divided by 16, that is 9. Minus 144 divided by 18, that is 8. 9 minus 8, that is 1. 1 divided by 144, that is 1. 1 divided by 144, yeah. So the integral of cos the power of 15 theta times sin power of 2 theta, the theta from theta equals 0 to theta equals pi over 2 is equal to 1 divided by 144. I hope you let us solve this question and get ready to see 1 year calculus week 9. Thank you.